In this video, we're going to do the Mod 3.5 investigation. Okay. Now, we're not going to do all of this, so just do the ones that we have done together. We're going to skip some of it. And then after this, you're going to need to open up your iMath. We're going to do one little thing together. Okay, so first let's start 3.5i. Now it says to use the graph provided to evaluate or solve each of the following, and approximations are acceptable. Now, when you see this notation, that means we have two functions. Here's our g function, here's our f function. And so we're going to start with the inside out. So let's start with g of 2.5. Now we're going to go over to the graph and we're going to estimate what is the height on the g function when x is 2.5. So here's 2.5. Go up to the g function. It looks to me like we have hit a height of 1.5. So this now can be replaced with 1.5. Now we're going to go over to the f function and we're going to ask ourselves, when we are on the f function at 1.5, what is the height? So find an x value of 1.5, go up to our f function and say, where do we end up? Well, I think that's really close to maybe, well, let's go, and said approximations were acceptable. Let's go to 3.2. Now, if you said 3.25 or 3.3, we're good. Let's do the next one. So we're going to start now with the f function. That's this one. When our x is 4, so go up to the graph. It looks like we hit 4 perfectly. So this hits a height of 4. So when you notice I worked from the inside out. Now, g of 4, we're going to go to our g function this time. That's this one. We're going to head to an x value of 4 and look what our height is. So it looks to me like we're just maybe about 0.8. Okay. Now let's look at C. In C, we're going to use the g function twice. Okay, so we are going to find g of 3.5. So when x is 3.5, we're going to go up to the g function. It looks like we hit a height of 1. Now we're going to use the g function one more time, but this time our x value is 1. So go to x value of 1, go up to the g function. I think we are just over the 2.5 line. Let's call it 2.6. And then finally, let's move to d. Now, you have to really contemplate what this means. We want to know, where is the f function? Okay, so let's ignore this for a moment. Let's say, where is our f function at a height? This is the height on the f function of 2.5. Okay, so let's go to a height of 2.5 and let's see what our x function tells us. It hits an x value of 1. I don't know, I would say maybe 1.1. So we know that the input has to be 1.1. Okay, so now the input on our f function has to be 1.1. So now we're going to go to the g function and we're going to go to a height of 1.1, which is about right here. We're going to look where it hits our g function, and I think it hits about right here, which looks to be about 3.25. So our x would be 3.25. Again, you're going to have to guesstimate. But that's how we use a graph to approximate some of these values. And you have to think about the output as your height, the input is your x value. The output is your height, the input is your x value. If you have a composition of functions, please start from the inside and work your way to the outside. Okay, so that is how we use a graph. We are not doing that one. I would like to go to 6, please. So in the 3.5 investigation, if we go to 6, the first thing says to draw a picture of the situation and the relevant quantities when a farmer has 250 feet of fencing and they want to create a rectangular pen for holding the animals. Now, the fencing is a perimeter, so not only do we need to know our perimeter formula is 2 L's plus 2 W's, but we know that total 2L plus 2W would have to equal 250 feet. And that's what leads us to what they wanted in B. Okay. Now it says to take this equation that we have found in A and let's solve it for W. So I've kind of highlighted my W there. So let's subtract 2 L's from both sides. So that's 250, take away 2 L's. And then let's divide by 2. Now, normally I would just say put it over 2, but both of these quantities are so easily divisible by 2. Let's just divide everything through by 2. And so we get W equals 125 minus L. Okay. Now let's go back to our picture for a moment. And let's put what we just found W to be. How is it related to L? Well, it's 125 minus L. So if the pen is 85 feet long, now remember, so that means that the length is 85 feet. We just found how the two are related. So the W will always be 125 minus L. Or in this case, they told us it was 85. So it's just 125 minus 85, or 40 feet. Now you can add it up. 40 plus 85 is 125. That would be 2 of the sides. The other 2 would total 125, 125, and 125. I've got 250, and I have 250 for the total fencing. So it makes sense they all kind of go together. Now it says, for any value of W, what must the corresponding value of L be? Okay, so for any value of W, the corresponding L, so if we go back to what we know, L equals 125 minus, or W equals 125 L. Let's rearrange that and solve for the L so that we know what is the corresponding value of L if we know W. So we would subtract 125 from both sides, and we would get that negative L by itself. Divide through by a negative, and we get that it's 125 minus W. Another way to think about it is they always total 125. So what is the corresponding area? Now remember, area is length times width. So if we call L 125 minus W times W, that would be a formula for area that only contains width. So that is really what they wanted in E, but let's use function notation. So A of W equals 125 minus W times W. Now, if we actually multiply that out, we would get 125 W minus W squared. Okay? Now, could you please, now I know that was 3.5, but we need to start thinking about 3.6 a little bit, and tomorrow we have a quiz. So I want to do pre-class M3.6 together. So at this time, could you please open that up? Okay. Now, again, please note that your numbers and my numbers might not be the same, but let's read what it says. We have this function f, which is x plus 5. We're just adding 5 to our x values to get our y values. So here's a little chart of those values. And it says function h is the reverse process of f. So h of u would take the h and subtract, h would subtract 5 from the input value of u. So I've written a function over here on the side to kind of guide us, so we just have that. So if we input 5, 5 minus 5 is 0. If we input 6.5, that's 1.5. 11 minus 5 is 6. 15 minus 5 is 10. Now, we have the original values. You'll notice on the original values, we had 0, 5, so our inverse function would be 5, 0. Then we had 1.5, 6.5. Our new function is 6.5, 1.5. So it reversed the x's and the y's. So let's look what happens if we do b. F of 0 on our chart is 5. So let's take that out and put in a 5. Now let's go to our h chart. H of 5 is 0. So the answer is 0. Let's do another one. This time we're going to start with f of 1.5. So if we go to this function, our input is 1.5, we get out 6.5. So now we're going to take the h and we're going to plug in 6.5. Oh, look what we got. The answer is 1.5. What's always going to be happening here, since these two reverse each other's processes, they're always going to go back, whether the f is in front or the h is in front. This one with 15 would be 10. F of 10 is 15. So all of these would match the initial input. So the function they're looking for here is h of u equals u minus 5 for me. Now, yours might be different, but that's what they're looking for there. So inverse functions, the x's and y's switch around. So if we go from the x to the y and back again, that's why all of these went right back to where they started. Now here, what they're showing you here is that if I start with f and go to h, it goes back to the original input. If I start with h and go to f, it goes back to the original input. So the inverse of a function reverses the process. There's a notation we're going to start using. The inverse, we use this little -1 notation. It is not anything to do with a power. It just means I am taking the inverse of f. So you just call it f inverse. So h, we don't have to call h. We could actually call it f inverse. And then that leads us to a few questions here. The function, this notation, is read as the inverse of f and can also be written as this. No, it does not mean a power, so that one's out. If the function j reverses the process of function g, then we could rewrite that as g inverse. Yep. And the last one says f inverse of f of x equals x conveys that composing a function and its inverse returns the value of the original output. Yep. So you don't want that one. And then finally, our last little bit and piece here. It says a rocket is launched upward from a launching pad, and the function h determines the rocket height above the launching pad given a number of minutes t. So I would even write h of t is the height, t is in minutes. Okay. So what does the equality h of 3 equals 587 mean? Well, it means that we are 587 miles above the ground 3 minutes after the rocket was launched. Now, this is not correct because we don't know if it was a constant rate of change. This, they're switched, so that one's out. That one's out, that one's out. And then, yes, it's above the ground 587 miles at the 3-second mark, but it didn't convey the two together. So I think the only answer we want is this one. Now, the inverse means, that little notation here means it's the inverse. So that means this is the height in miles. The input is the height. The output this time is minutes. So let's just find the one that goes along with that. So I am at a height of 1,089 miles above the ground, and we're at the 7-minute mark. So this would be the one that we want right here. So they're just starting to get you to understand that notation and how they reverse each other's x's and y's. So that should be done for you. And there is a quiz review that we're going to do now.